Edexcel January 16 International paper. Here we go. First question is a discrete random variable question, and we've got a situation here where we've got all the values up to 4 here. So F5 is a probability that's defined as probability that the random variable takes a value of less than or equal to 5. It can't actually be equal to 5. So in this case, it means all of the 4 that I've just marked here. So that basically means 1 minus the 1 here. So that's 5/6. Okay, e to the x, there is a formula for it in the formula book. And it's basically sigma x p x equals to x. So basically that times out, that plus that times out, plus that times out, plus that times out. So that equals to minus 2 times a quarter plus 1 times 1/6 plus 3 times a third plus 4 times 1/12 plus 6 times 1/6. Work all those out, and that comes to 2. The variance of x, it's e of x squared take away e of x squared like that. So that's basically this squared times 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 this. Take away the mean squared, that's squared. So that basically is minus 2 squared times a quarter plus 1 squared times 1/6 plus 3 squared times 1/3 plus 4 squared times 1/12 plus 6 squared times 1/6 minus the mean squared, which is 2 squared. Work all out and you should get the answer 23/2. Oh no, so 7.5. 23/2 is just this bit here. So that's equal to 7.5. Okay. So that is the first 2 parts done. Now we've got a combination of discrete random variables. Now there's 2 formulae here that are not ones in the formula book, but you just need to be aware of. It's if you've got a linear combination of something, then it's a e of x plus b. But the variance of x, variance of ax plus b, the b doesn't, because adding a number to a set of data does not change the variance. So that just comes to a squared variance of x. So e of y here would just be equal to 7 minus 2 e of x. So that's 7 minus 2 times 2, so that's equal to 3. However, the variance of y, as I said, the 7's not going to, the adding number is not going to have any effect whatsoever. So it's minus 2 squared times variance of x. So that's 4 times 7.5, and that equals to 30. Okay, then it says the probability that y is greater than x. Right, okay, so what we've got is, what we really need to find is the value of y where it is greater than, where that comes to greater than x. So if y is greater than x when 7 minus 2x is greater than x, so we just need to solve that. So we get 7 is greater than 3x. So x is less than 7/3. So that basically 7/3 is just that's less than 3. So it's basically these two added together. So it's 1 or -2 or 1. So that equals. So that means the probability that y is greater than x is equal to those two numbers added together, 1/4 plus 1/6. So that equals to 5/12. Okay, not too bad a question to get us into the paper. Let's have a look at question 2 now. Question 2. Okay, we've been given a stem and leaf chart. Some of my students thought this was a misprint when I gave this, but it's not, as you'll see later. It's not something that's not come out in the printing. Figure 2 shows part of a box plot for marks in an examination with a large number of candidates. Part of the lower whisker has been torn off. There we go. So that's obviously there's going to be a question about that. Given that 75% of the candidates passed the examination, state the lowest mark to award for a pass. Well, you just need to understand what the lower quartile is. This is Q1 here. So therefore, that is equal to. So that is equal to 25% are less than that, and 75% are more than that. So the answer is just that number that I've marked there, 30. It's only one mark, but yeah, it's 30 because that's what, by definition, what we mean by the lower quartile. Okay, so the next question is, given that 25% achieved a merit mark, state the lowest mark for the award for merit. Well, same thing. It's 46 because we've got 25% being greater than the upper quartile by definition. Then it says an outlier. It's about outliers again. They've given this definition of outliers. Sometimes this number gets changed to 2 or even 1 sometimes, but the idea is the same. Find the values of C and D. These are the boundaries where we consider which we're going to judge whether a number is an outlier or not. Well, C, let's just do that. C is equal to the Q3, so that's 46 plus 1.5 times the interquartile range, and we can see that the interquartile range here is 16. That's 1.5 times 16, so that equals to 24 plus 46, so that equals to 70. 70. Okay, so that's the upper boundary. The lower boundary, that's D they've called it, is the lower quartile, which is 30. Take away 1.5 times 16. So that's 30 minus 1.5 times 16, so that's 24, so that equals to 6. Okay, so that's the boundaries for it. Then it says write down the 3 highest marks scored in the examination. So we've got the highest mark here is 79. The highest, the next mark here is 72. It really is that obvious. The next mark here is 68. Now you may have seen in other work where they use the boundary for the upper thing, but normally if we know what the largest number is, or the largest number apart from the outliers, we put that in as the mark for the largest value rather than the boundary that we've just worked out. So it's definitely those three. So then it talks about the three lowest marks in the examination are 5, 10 and 15. On a diagram, complete the box plot. That's not going to be difficult, is it? It's going to be absolutely fine, because we're going to 5 is going to be the outlier. Okay, and then the next lowest is 10. And they've made it clear that they're not going to allow us to use the boundary here, because when we know the next lowest value, that's what we should use for our box plot. So okay, let's have a look at the box plot. Or maybe need to expand that out a bit. Need to make it a bit bigger. Okay, it won't be this big obviously if it's in the exam, but okay, so we've got the number 5, which is the lowest there, and then we've got the next lowest is 10, but that's not an outlier, so that goes there and there. Okay, no problem with that. Not too bad so far. So on the diagram on page 7, complete the box in which we've done that. 3 candidates are selected at random from those who took this examination. Find the probability all 3 of these candidates pass the exam, but only 2 achieved a merit mark. Okay, there's a bit of a probability thing mixed in here, so it's kind of, just testing something completely different. So it's a little bit of a curveball, I suppose, because it's not normal stuff you expect in this type of question. Anyway, I don't think it's too bad. We've got here, first of all, 3 of these candidates passed the exam, but only 2 achieved a merit. Only 2 achieved a merit mark. So that basically means that we've got 75% of if they've passed and not achieved a merit mark, that's anywhere along there, because the pass mark is 75%. And a merit mark is the pass mark is not 75%, but the pass mark is the lower quartile. Anyone who's above the lower quartile passes, and anyone who's above the upper quartile gets a merit. So all these students here get a merit. All these students but get a pass mark but not merit. The ones in the middle, kind of half there in the main box bit here. So this is 50% of them, and this is 25% of them. And they want the probability that there's 3 of them. So note that this could go in 3 different ways. It could be pass, merit, or then the second person could get a merit, and the other 2 get a pass. Or it could be merit, pass. There's 3 different combinations for that can happen. So we're doing 3 times the probability of getting 2 merits. That's 1/4 times by 1 pass mark, which is a half, because in that middle half there. And working all that out, we get 3 out of 32. Okay, let's have a look at